booklet again. As I was asking you right now to look over these, all these properties, they're given right by the province. This handout is given by the province. So that kind of like the expectations, what you should know after this unit. Daniel, could you turn off the lights first? Okay. All right, so open your books, pencils, calculators. Most of these questions are not going to require a whole lot of calculations. This unit has to do more with properties. So if you can get around those properties, you will be fine. So you really want to make sure your study sheet is updated. Okay. So basically, this is the Richard and Jordan, pay attention now. Okay. This is the order in which we're going to cover things. Okay, so just use this space right here. First, we're going to talk about triangles, right? So we're going to talk about all kinds of different triangles, right? So triangles. Then we're going to move over to quadrilaterals. Right? I call them quads after quadrilateral. Boy. Right? Quadrilateral, so any four-sided shape, that's the next we're going to study. And then we're going to talk polygon, so try to make a pentagon if possible, right? So, and then you have your stop sign, 8 sides, right? Polygons. So that is the order in which we're gonna spend some time in triangles. Most of the stuff in triangles you're gonna know, but we're gonna dig a little deeper into the properties. How are the angles and the sides related? How can you find angles if you know? And so the naming and all of that will be important. Quadrilaterals, anything four-sided, right? So how about this? You put down 4 sides here. And then polygons is many sides. Triangles obviously is 3 sides, right? I don't need to tell you that, but I don't know, sometimes just watching the pattern helps, okay? But really, at the end of the day, you're going to realize that all of the shapes we talk about are actually polygons. A triangle is a polygon. A quadrilateral is also a polygon. So this is kind of like an over-encompassing polygons, kind of has them all in it, but that's how we're going to progress, right? How about this? To be accurate, under polygons, we're also going to add triangles, and we're also going to add a parallelogram. Okay, so it's all shapes. All shapes are included when we get to polygons. Okay, so now that's kind of like an overview of what we're going to be doing in this unit. So it's about 8 days. So before November 5th, you're going to be tested already. So then that'll be the 3 tests that make it to the report card. Okay. Yep. Time flies. Okay. So working with right triangles, I need to review Pythagorean theorem. So write that down. Pythagorean theorem, because we're going to use it quite often in this section. And I need you to be quick. Okay. I need you to be fast and figure out. And there are 2 cases. And this might be the quickest crash course on Pythagorean theorem that you've ever had. But the longest side across the 90, we always call that the hypotenuse. I think you knew that already. So anyways, there's the hypotenuse. The other 2 sides are called legs. So we call this leg 1 and leg 2. And basically, there are two cases. If you're missing the hypotenuse, right, you would use this formula, knowing that c squared is equal to leg squared plus leg squared. And I would like to replace c with hypotenuse, sorry about that, because the letters are going to throw you off, right? Just know that the hypotenuse is leg squared plus leg squared. So if you find the longest side, which is always across the 90, hypotenuse squared is leg squared. Therefore, the hypotenuse is going to be the square root of leg squared plus leg squared. Okay. The other case is missing leg. It could be leg 1 or leg 2. It doesn't matter which leg you're missing, it's the same steps. And this is how it goes. Leg squared is going to be equal to the hypotenuse squared minus the other leg squared. So that's how it's different, right? I need to subtract. So therefore, leg, just to get one of the legs, you would just take the square root of hypotenuse squared minus leg squared. And that's basically the two versions that you need to know. Okay? And for this to work, right, it only works with right triangles and need to know at least two sides. That's the only way this will work for us. So as soon as we see that 90-degree box, we know it's like, yeah, we can use Pythagorean theorem, provided we know any 2 out of 3 sides. We can go ahead. So you don't need to use sine law, cosine law to find the third side. Okay. So there you go. Now we're going to put it to use. Back side. I want you to scratch off the primary trig ratios. I don't want you to use them because then you mix up sine law with them, okay? So forget about those guys. SOHCAHTOA, remember that? Don't worry about it. You're not going to go there. The book wants to, but I decided not to because I had students on an exam use SOHCAHTOA on triangles and it doesn't work. Most of the time it will not work because we're not always dealing with right triangles, okay? Example 1, calculate the length of the missing side. And so this is our right triangle. 2 of 3 sides known. Okay. Therefore, use Pythagoras. Pythagorean theorem. So again, across the 90, this is the hypotenuse. So you are missing, right? This is your unknown. You're missing your hypotenuse. So see how they labeled that A? You see that letter? You always learned that that's letter C, right? Most teachers like, hey, C is always, and there's A. How come? Well, don't worry about it. You know it's your hypotenuse. So I'm just going to say that hypotenuse is going to be, if I want to know the hypotenuse, I need to take the square root of leg squared plus leg squared. Sorry, that doesn't look like leg, does it? There. Leg squared plus leg squared. So if you know your hypotenuse, these ones are referred to as the two legs of the triangle. So it doesn't matter which order you put them in. We're just going to go 7.6 squared plus 9.4 squared. And maybe I should have done it. I shouldn't have done the square root or right away, but I think you can handle it. Square root of, let's enter that into our calculators. This is where you need a good calculator. If you haven't spent the money, I strongly recommend getting a good calculator. It'll be the best 14 or 15 or 16 bucks you've ever spent. And it's yours. And you're probably going to use it for post-secondary if you want to do anything, Red River, whatever. You usually need a good calculator. 12.09, right? Let's do the rounding here. It's 0.88. That 8 bumps that to a 9. For the most part, rounding is done very well. So you can give yourselves a pat on the back for rounding, okay? It's done. A lot of you are learning and you're getting really good at it. Make sure you include units, right? Same old. By the way, this is now an SSS. You can use cosine law to solve all angles. You could also you can use sine law because you have a pair, right? You could use sine law to find all angles. You can do that now if you wanted to, but we're going to stop there. Okay, next. Can you practice on 176? Just quickly apply your knowledge of Pythagorean theorem to do this. I just want you to review it quickly. You do it so that you can make corrections. And watch this. C is a little trickier, but I think you can handle it. C is a two-part question. So go give that a try now. I will just do a quick run through. So across the 90, that's the hypotenuse. That means that this is leg and this is a leg as well. So you're missing your hypotenuse. So you can use that letter if you want, right? Y is equal to square root of 69.3 squared plus 47.6 squared. So you're adding the legs. And that gives you, let me just look at the key here. That is 768.25. And so that's 8407 centimeters. It better be the longest side, right? This one, across the 90, that's the hypotenuse. So this is leg, and this is another leg. So you're missing a leg, which is A, right? So to find A, you take the hypotenuse, you square it, you subtract the other leg. It's really that simple, folks. It's either adding or subtracting the squares. Okay? And so this is 6,021. Just make sure you show me the steps. And we are in millimeters. So that's your, and it should not be longer than the hypotenuse. Always do a little check there in case. And then the last one there, I want to talk about naming these guys yet. So when you have one like this, you got to start with the one that has most information, okay? So you have two sides here. So I'm going to start with this one. This, I'm going to call this X here. For this particular triangle, this is a leg, right? Because you have the hypotenuse here. And so it's leg and leg. So to find X, I have to go hypotenuse squared minus 68.4 squared. And that gives me square root of 3331.69. So X is going to be 5772 centimeters. But that's not my answer yet, but that's important to me. because these ones get tricky, okay? The second triangle here, this is the hypotenuse, and this is leg still on this side, and this is a leg as well. So these, in fact, it's the leg for both triangles, so we're good there. But you're missing the hypotenuse, so you're going to go P is going to be square root of leg squared, which is the one you just found, plus the other one you're given. You got to add, right? Because it's hypotenuse that you're missing. And that is 5531, 2084. And so P is 7437. That's the final answer there. So thinking caps, they could have made this side that is touching this triangle the hypotenuse for the second one. So you just watch out how that is done, okay? Okay, let's keep going. I will skip a bunch of pages here because we just did trig. Okay, so everything here is trig, trig, trig. I will get you to come back to it in a bit. I want you to go to 179, page 179, where it says working with properties of triangles. And I want you to highlight that. Okay, it's important. A property is a characteristic that classifies the object and distinguishes it. So distinguishes it among other objects of the type. What properties describe a triangle? In general, right, has three sides. A closed figure. The sum of interior angles is 180. No news there. But here's where I'm going to teach you, I guess, how to name it. Okay, triangles can be classified. This is important. Triangles can be classified by their side lengths and sizes of the interior angles. Can you underline side length? Side lengths like this, and the interior angles. Just make sure that that's emphasized, or circle it. But we name them by the side length and the interior angles. Okay. So you have acute, right, and obtuse. This is by angle measure. Okay, if you want to do angle, if you want to classify a triangle by angle, there's acute, all three measure less than 90. Right, one angle must be 90. Obtuse, one angle is greater than 90. So right there, that's the obtuse angle because it does look greater than 90. Always think of a 90 is right here. So this is greater than 90. So no news there. Acute, right, obtuse. So just know that if I ask you to name it by angle measure, these are the three options you have. And then we go over to page 180. Here is by side length. Right? Triangles are classified by side length as well. Equilateral, so I'm going to highlight that. Equilateral, isosceles, scalene. Equilateral, obviously, three sides of equal length and three angles that are equal in measure. And this is, I'm going to make a little note here. Can only be acute. You cannot have an equilateral triangle that is obtuse. You cannot, because in fact all three angles of an equilateral are always going to be 60 degrees, guaranteed. It doesn't matter how big it is. If all three sides are the same. It's always going to be 60, 60, 60 because that adds up to 180, right? Isosceles, two sides are of equal length, two angles are of equal measure. Okay? And I'm going to emphasize this. These kind of go, like if this side is equal to this side, then the angles across from them are going to be equal as well. Okay? And why am I saying that? Because sometimes you're given, let's draw this like this. You're given a triangle like that, and you're told that these two sides are the same. Then the angles across those two sides are going to be the same. So you kind of follow it. You go arrow to this and arrow to this angle. These two angles are going to be the same. So it's always the angles across the two congruent sides are going to be the same. Scalene, all sides are of different length and no angles are of equal measure. All angles, all sides are different. Okay? So here we go. Let's now go back. And no, we're not going to go back today because we're not going to have enough time. I'll get you to do that on Monday. Let's keep going here. And let's put into practice. So, okay, listen carefully. I expect you to be able to solve for angles and sides by now. So sometimes you're going to have to do that before you're going to be able to name the triangle. Okay, you need to know about their angle measures and whatnot. Okay, so we're gonna figure out what is the length of side BC. Side BC is from here to here. Right, this here is side BC. And here's where I'm gonna use a trick. Right, this is a symmetric triangle. Symmetric means that if you cut it in half, cutting in half, comma, results in two equal triangles. That's what symmetric means. Symmetric is if you cut it, you have two exactly same halves here. And we know that it's symmetric because of this. If this and this, if these are the same, then the angles across from those sides, so if you cross it here, that's 53. What is this going to be over here? Well, you guessed it, it's going to be 53 as well. Okay? So I want to highlight that right off the bat. So we're going to take this, it doesn't matter, if this is 20, we know this is 20 centimeters as well because we're just being told. So try to fill in as much as you can when you're given markings like that. What's the length of BC? I'm going to do this. I'm going to figure out if this is X from here to here, then this is X as well. So I'm going to find X and just multiply it by 2 to give me the whole thing. So X is here. This is 53. This is 16, right? I'm told that this is 16 and this is 20. And I can use Pythagorean theorem to solve for X. X is a leg, right? Because leg, hypotenuse. So I'm missing the leg here. So it's going to be square root of 20 squared minus 16 squared. That is going to be, is that 144? Just going to double check. I actually didn't solve that. Yeah, it's 144. And so square root of 144 is 12. And we are in centimeters. So now I can say that the length BC, like from end to end, is going to be 2 times that number. BC is going to be 2 times 12 centimeters. BC is 24 centimeters. That's what they wanted. Why did we do that? Well, there was a chance, there was a possibility that perhaps this could have been an equilateral triangle. Well, not really, because we have 53 and 53, right? But we answered this question. So now classify ABC by angle measure and by side length. And by angle measure, we have 3 options. So I'm going to show them to you. We have acute, right, or obtuse. It's definitely not obtuse. It's definitely not a right triangle. So this will be an acute scenario. I will do this though. Angle A, which is at the very top of this triangle, angle A, which is right here, is going to be 180 minus 53 minus 53. And that's 74 degrees. Okay? All angles are less than 90. You don't have to give me this much explanation on a test or quiz. But therefore, triangle ABC is acute. Okay? When it comes to angles, it's acute. By side length, I will say this. If you think about it, you have this side that is 24, and these two sides are 20. Okay, you will say 2 sides are equal. Therefore, triangle ABC is isosceles. So we concluded that it's acute by angle and isosceles by side length. So to conclude, triangle ABC is an acute isosceles. Okay. It's an acute isosceles triangle. So we basically put together these 2 names, and that's how you name it correctly. And by the way, you don't have to do this, you don't have to go through this great length to name it, but it always has 2 parts, right? This, then this. So when you have to name something, you have to have both components there. Both components. Let's keep going. This you have to have practice a couple of times before you can wrap your head around it. So I'm going to give you a few examples here. Classify the following. This is on page 181. Okay, so A, So copy these down. Make sure the markings are there. So for each one of them, I want you to see if you can figure out, each one of them has a first name and a last name. Okay? So by angle measure, by side length. Angle measure, side length. Each one of them has those two. Let me zoom out a little bit. Okay. This is super exciting stuff, right? Being able to name a triangle. Can you imagine that? It's a very unique opportunity, folks. You copied them. I will go through it because I don't have a whole lot of time here. But this one, the first one, because you see the 90, this is definitely going to be a right something, right? So by angle measure, it's a 90. By side length, all sides are different, right? So what name is that? It's a scalene. A right scalene triangle. And then this B, what would you make of that? Are you going to answer, Connor? Or? Yeah, go for it. Sorry? It's an acute. This beats it though. So it's a right. The right beats everything because it's specific. What else can you tell about the side lengths? It has two sides that are the same. So Ben? Isosceles, yeah. Yeah. I know. You don't use those words on a daily basis. I don't think it comes up on regular conversation with your friends. So it's a right isosceles triangle. You're right. Yeah. What about this one, C? In terms of angle, this one will tell you that it's obtuse, right? I always like to do angle first, then measure side lengths second. And you know these markings, 1, 2, 3, that means that all three sides are different, so scalene. It's an obtuse scalene triangle. Oh, the bell is going to go. This one is an equilateral. You don't have to say acute equilateral. You can just say equilateral. This one, if this is 25, then this one will also be 25 because they are the same. So 25 and 25 is 50. So this will be 130, right? Because I figured out these. So this is an obtuse isosceles. Obtuse isosceles. So a little bit of math required here and there. If this is 45, then this one over here is 45 also. So 45 and 45 is 90, right? Yeah. Oh, yes. This goes till 45. Sorry, I was thinking 1020. Oops. Is it Monday or what? Feels like Monday. That's how I work on Mondays. So I can relax a bit. Okay, good. Thanks, Joey. Because the 45 and 45 is 90, I know that this is a 90, right? Not just because it looked like it, I actually went for and checked, right? So this is a right isosceles. I rushed for no reason. Okay, we're gonna keep going. So, okay, let's say here for a second you're not so sure how I did these, right? Try to get as much information out of that triangle as possible. Try to fill in what you know, and then answer it if you're not sure. Because this one, right, it wasn't apparent that there was a 90 at first until you did a little bit of work. So sum of angles being equal to 180 is going to help you big time, as well as Pythagorean theorem. Okay, so let's flip over here. And I will want you to work through that page. Now that I don't need to panic time-wise, 182, I want you to work through that and just answer as much as you can of that and see if you can put that into practice. This goes all the way to 183. Okay, so work on page 182, and it goes from questions 4 all the way to 6. Right, 4 to 6, there's one question that is on the back side. So try to do that right now and see how much you can do. You know more than you think, okay? And if anything isn't clear, I will clarify that later on. Finish off by going over these questions. Some of you might not be done, that's okay. So if we go back to 182, question 4, even if it didn't walk you through AV and so forth, if you were asked to classify, you should, maybe I'll use a different color so that it sticks out, right? I use a red pen. If this marking is the same as that marking, I can transfer the 50 meters over here. Okay? That's going to be the key in this unit, if you can fill in the information just by looking at the markings. Knowing that 15 has a 60 across from it, I will automatically know that this side will also have a 60 across from it. I can just assume that. It's as clear as, right? Like you just assume that. You don't have to even calculate or do anything like that. You just assume. Okay, so you've got two angles already and two sides. That's for sure in the isosceles category. So what's the angle measure of M up here? And M, you will realize that can be found by going 180 minus 60, right? And you find out that M is 60 degrees. Okay. Now that you know that, you can fill that in too. And you're like, wait a minute, if this is 60, if all angles are the same, then Is it fair to do this down here? Absolutely, because all three angles being the same guarantees you all three sides being the same. Okay, so we've got that. So classify MNP, triangle MNP, by angle measure and by side length. And so this is simply an equilateral triangle. You can say, if you want to, you can say an acute equilateral. I will not take marks off for that, but we don't need to say that. All right, keep going. Use the following diagram to answer the questions below. What's the length of PR? So they're asking from here to here, that is side PR. And so markings, again, I'm using the red pen, so or anything different color so it sticks out. If this is marked like this and this like that, that means that the 8 goes here. And watch this, you have a right triangle here. If you look at this triangle, there's our 90 in this corner, so leg and leg, we're missing our PR, right? So, oh, I don't like to use pen on my work here in case I make a mistake. PR is the hypotenuse, so I'm going to have to go 8 squared plus 8 squared. And that's going to be 64 and 64, which is 128. So PR is going to be 11.31 meters. You can call that X if you want, or you name it. Just label it clearly on the diagram. So you've got that figured out. And notice you'll see that a lot. They split a triangle into two, so you get used to that. So it's saying classify triangle PQR. So PQR is this triangle right here, and we know that it is a right. Because of this, it's a right triangle. And what else? Isosceles, right? Okay. Perfect. So that's taken care of. Classify triangle QRS by side length. That should be by angle measure and side length. But anyways, QRS, they're talking this triangle here. And remember supplementary, like if this is a straight line, these add up to 180. So this is also a 90 here. So it is a right. What can you say? What is this going to be? You think it's going to be an isosceles? Well, because it's a symmetric, this is symmetric. So if you cut that in half, you're actually splitting this in half. Okay? So it's half of that. You know what else I'm going to do? I'm going to do this. Watch. What are we time-wise? Here. If you take this triangle out, just take it out here for a bit. Like that. And you have the 90 there. And this is S, Q, R, right? If so this is 8 here, 8 meters. And these two sides here, what do I know about them? If I split that in half, I can't really guarantee that these are going to be the same. I can't guarantee that. So what I have to do is, but I do know that this is half of that. So I'm going to take this, and I'm going to divide that by 2 to get this. Some of you might have done it a different way, and that's fine. That's 5.66. So to find this, which we can call lowercase r, right? Because it's across capital. Sorry, you can't see that, can you? This is lowercase r, so I'm going to figure that out. So r is a leg, so I'm going to go 8 squared minus 5.66 squared. That is 64 minus 319644. Square root that. 5.65. It's almost. And some of you might have, if you use all decimals, it might actually give you the same. So this is in meters. So technically, all three sides are different by a little bit. And this is a controversial example. So if you put down isosceles, I'll give it to you, but I will put down scalene because technically they're all different. Okay, write scalene. Yeah. Did you sign up? Okay, go ahead. Go ahead. Ah, yes. He's still there? Okay. I checked once, but see you over that. Yes, okay. So Jaden has a good point here. She saw that this 45, this 90 is being split in half, right? This 90 here is being split in half, so this must be 45 degrees. And if so, this is 90, right? So if this is 45, this also has to be 45. Okay. So then technically it is isosceles. So it's a bit of a controversial example. If I had used all decimals for this side here and then split it, I would have probably come up with the exact same 5.66, which would have also indicated isosceles. So what do you want, isosceles? Let's do isosceles because they're so close. I wouldn't do that to you, right? I wouldn't. What's that? If you go by, if you wrote down the 45s here, I would put isosceles. If you didn't write down the 45s, then it's okay to put scalene. Okay, we'll leave it there. We'll come back on Monday.